So let's take a look at this example for points of inflection. So we are given this graph of fx equal to x to the power of 5 over 3, and we know that it has a horizontal tangent at the origin, because if you find the first derivative, that is f prime x, you'll get 5 over 3 x to the power of 2 over 3. So just a simple power rule, and it is equal to 0 when x is equal to 0. However, the second derivative, let us find it together. So we have f double prime x is equal to 5 over 3 times 2 over 3, and then we have x, 2 over 3 minus 1, that gives us negative 1 over 3. So we can simplify this to get 10 over 9 x negative 1 over 3. So this fails to exist when x is equal to 0. It is undefined when x equal to 0. Nevertheless, we know that f double prime x, f double prime x is less than 0 when x is less than 0, and f double prime x is greater than 0 when x is greater than 0. So you can try to plug in the values. So we know that at that particular point is where the concavity changes. From here we have less than 0. For the first part here we have less than 0. It means that it is concave down. And for this part here, the second derivative is greater than 0. So it is concave upward. So at this particular point, x equal to 0, the concavity changes, and it has tangent. In this case, we have the horizontal tangent. So we say, or we make conclusion that there is a point of inflection at the origin. Let us take a look at the second example, that is y equal to x4. So we need to decide whether there is a point of inflection here. So of course we know that y equal to x power 4. It's pretty obvious that it has no inflection point at the origin or when x equal to 0. You can refer to the figure here as a reference, of course. Even though the second derivative we have what? Y double prime. That is fine. Y prime first. So y prime here is 4x cubed. And then we have y double prime to be equal to 12x squared. So we can see here we have 12x squared. Even though, remember we have two conditions just now. First one is y double prime, or the second derivative is equal to 0, or second derivative is undefined. In this case, when x is equal to 0, our second derivative 12x squared is also equal to 0. But notice that the concavity does not change sign. For any value that you plug in here, for values less than 0, you get it to be positive because of the square here. And also when you plug in the values that is greater than 0, from 0 to infinity, you also have positive value. It means that for both part of the intervals, negative infinity to 0 and 0 to infinity, both concave upward. So concavity does not change sign. It means that we don't have a point of inflection there. Alright. So in this next example, we have the function y equal to x 1 over 3, and it has a point of inflection at the origin, based on this function here, because the second derivative is positive for x less than 0 and negative for x greater than 0. So let us try to find the second derivative together. So we have y double prime equal to d square dx square of function 1 over 3. Let us do this one by one. So we have here, if we perform the first differentiation, we have 1 over 3 x. 1 over 3 minus 1, you have negative 2 over 3. Alright, and then you can proceed with second derivative. We'll have 1 over 3, and then you have negative 2 over 3, and then you have x, negative 5 over 3. So upon simplification, you have negative 2 over 9 x to the power of negative 5 over 3. Okay. However, both y prime and y double prime fail to exist at x equal to 0. If you plug in the values, okay, we have, of course, we have this at the denominator, so it fails to exist. And there is a vertical tangent. Okay, remember the condition that we need there, we have a tangent, so it still have a vertical tangent there, and the concavity did change the sign. That is for x less than 0, it is positive. Okay, positive here, concave upward, and we have negative for x greater than 0, concave downward. So concavity changes sign. We have the vertical tangent in this case, so we make the conclusion that it has a point of inflection at the origin or when x equal to 0.